Hello, welcome to another section in further maths, and still in the spirit of polynomial, because for some time now we've been dealing with this. I would like to further move on the topic that says factorization of polynomial. Now, when you talk about the factorizing a polynomial, there are certain things that we really need to recap from our previous lesson. So before we move further, I would like us to take a clue of what happened in our last lesson. Okay, welcome back. Now let's go into factorizing a polynomial. For example, if we have a quadratic expression, let's say x squared plus 5x plus 6 equals 0. Now, if you're asked to factorize an expression like this, what you need to do is to look for two factors that if you sum them up, they'll give you 5. If you multiply them, they'll give you 6. And no other factor is suitable than x squared plus 2x plus 3x plus 6 equals 0. So it's 2 and 3. Because 2 times 3 is 6 and 2 plus 3 is 5. So with this, we now have x in bracket x plus 2. They also have plus 3x plus 2 equals 0. So we now have x plus 2, x plus 3 equals 0. So these are the factors of this expression. But today, let's learn how to factorize a polynomial. I think one of the best way you can get the factor of a polynomial is by applying the remainders theorem, just like what we have in our last lesson. Now, let me say, for example, you're being given a question like to check if 2x3 plus 3x2 minus 5x minus 6, to check if x minus 1 is a factor of this polynomial. Check if it's a factor of this. Now, what you need to do, remember our remainders theorem. This is fx. Before you forget, this fx. Now, what you need to do is to solve this. Equate it first to 0. Minus 1 equals 0. So our x is equals to 1. Now, let's add x into this and see if our answer will be 0. Now, by this, we now have 2. 1 raised to the power 3 plus 3. We now have 1 square minus 5 with a 1 here minus 6. Now, after coming to this point, you now have 1 raised to the power 3 is 1. So this is 2 plus 1 square is still 1. So 1 times 3 is still 3. And minus 5 and minus 6. So let's move ahead. If you have 2 plus 3 is 5. And 5 minus 5 is 0. So without this, let's say this is 0. This is 0. This is 0. So you now have 5 minus 5, which is equals 0. So since this give us that same value of 0, then this expression is a factor of this dividend. So when you apply the remainders theorem and the value of your remainder is 0, just know that the divisor is a factor of the dividend, just like what we did in our previous class. Now let's try this other expression. We can call this, can actually refer to it as example 2. Example 2. Show that x plus 1 is a factor of f this is x equals x3 plus 2x2 minus 5x minus 6. Now remember the rule, x plus 1 is equals 0. You equate it to 0, so therefore x is equals minus 1. So you look for f minus 1. If f minus 1 gives us 0, then x plus 1 is a factor of this polynomial. So we have minus 1 3 plus 2 in bracket minus 1 2 minus 5 in bracket minus 1 and minus 6. So minus 1 3 is still minus 1. Then plus minus 1 2 is 1 times 2 is 2. Minus 1 times minus 5 is plus 5. Then we have minus 6. Now let's add minus 1 plus 2 is 1. 1 plus 5 is 6. 6 minus 6 is 0. Now you've seen that using this into this, the remainder, according to Remender's theorem, we have 0. So therefore your conclusion will be, since the remainder when fx, that is x3 plus 2x squared minus 5x minus 6 is equal, divide by x plus 1 is 0, then x plus 1 is a factor of the polynomial. This is a very good conclusion from this. So this is actually how to get the factor of a polynomial. So in some of the instances, you might be asked, you might be given a factor, you might be given a polynomial. Let's say a polynomial of this form. Let's go with 2x3 minus 3x2 plus 4x minus 1, and I say factorize completely the polynomial. Now you're being needed to factorize this, but remember, no value was being given to you to divide with so that you could apply the Remender's theorem. In a situation whereby nothing is being given to you, you make use of the try and error. Now what the try and error talks about is, you start trying numbers, and as soon as you get the first one, you apply it, and whatever thing your answer gets, then you now use it as, each time you get 0, then that number actually is a factor of the polynomial. Now let's try plus 2 plus or minus 2. Let's just try it. Okay, plus or minus 2, that is to say, let's put 2 here. We now have 2 in bracket 2 raised to power 3 minus 3. This is what 2. Remember, we are trying to square plus 4 2 minus 1. So let's see if it will give us 0. Now 2 here is 8. 8 times 2 is 16 minus 2 here is 4. 4 times 3 is 12 plus 4 times 2 is 8 minus 1. Now let's see. 8 plus 16 is 24. 24 minus 12 is 12 minus 1 is 11. So 2 is not a remainder. We try another value. Let's say minus 2. So this 2 minus 2 raised to power 3 minus 3. We now have our minus 2 square plus 4 minus 2. We now have minus 1. So with this, we move ahead by saying minus 2 here will give you minus 8 times this. Minus 8 times 2 is minus 16. Here will give you 4. 4 times 3 is minus 12, which is still here. That's a minus 2. Then minus 2 and 4 times 2 is 8, so it's minus 8 minus 1. Everything is minus, so minus 16 minus this is minus 28, minus 36 and minus 37 equals minus 37. So none of this number happen to be this. Can we just go to plus or minus 1? Now let's start with minus 1. 2 in bracket minus 1 raised to power 3 minus 3 raised to power minus 1, 2 plus 4 minus 1. Then we now have minus 1. So this now gives us minus 1 into 3 is still minus 1 times 2, which is minus 2. And in this other side we have this, we still have a minus 3, and here we have minus 4, and also we have minus 1. So minus 2 minus 3 is minus 5 minus 9, which is equal to minus 10. Now this is how the procedure will continue until you search for a particular number that can give us 0. Then when you get 0, that becomes a factor of the polynomial. So I think we continue from there, and don't forget that standard equation still remains 2x3 minus 3x2 plus 4x minus 1. Now let's do plus or minus 3. Let's go with 3. Now we have 2 with 3 raised to power 3 minus 3 raised to power 2 plus 4, and this minus 1. So with this we now have 3 raised to power 3 is 27. 27 times 2 is 54. Minus this is 3 to 9. 9 times 3 is also 27. Plus 4 times 3 is 12, and this minus 1. So with this we're having 54 minus 27, which is 27. 27 plus 12, which is 39, minus 1 is 38, which is not still a factor. Now let's try minus 3. Now we are going with minus 3. We now have 2 minus 3 raised to power 3 minus 3 square plus 4 minus 3 and minus 1. So with this we now have what? Minus 54, and this minus 27 minus 4 times 3 12 and minus 1. So minus 57 is 81. That's minus 81 minus 93 minus 94, which is not still a factor. So you continue until you get a factor that will give you equals 0. I think with this we have to continue in our next class, but do me a favor by trying to refresh on what we've done, and make sure you also go through this platform in trying to get some evaluations that will assist you in solving other questions. So feel free to always drop your question on the comment section. We'll give response to it. Thank you. See you in our next class.